humidity and wind. And then further, if we are going to uh, check it you with respect to humidity values, high and normal, and for wind, weak and strong. So we'll see that when humidity contains high value, so all the records belongs to no. And when humidity contains the normal value, then all records belongs to no. Similarly for wind, weak, when it takes value weak, then all records belong to class yes. And when it takes the value strong, then all records belong to class no. So we can see here these square boxes are representing the leaf nodes or terminal nodes. And if you look at the records, so these yes no values are indicating the label of the records. So we are not having any kind of mixture, I mean, yes no type. Either it contains the records belongs to no, or it contains belongs to records belongs to class yes. So this is the objective of this id3 algorithm. And we can see here how it is interpretable. We can see that how attributes are being selected. So this particular algorithm is not only it can be used for the classification problem, even it can be used for the feature selection also. Features, how it can be used for feature selection. I mean, when we are going to select the features out of some given number of features, so the feature which is going to give the highest information, that feature will be selected. And we can see that highest information gain representing the this is the most valuable feature. So decision tree, not only it is a kind of interpretable machine learning algorithm, even it can be used for the multi purposes, like for the classification and for feature selection. Similarly, there is another algorithm, another variant of this decision tree, cart algorithm. I'm not going to discuss here. It will take time to discuss. So one algorithm is discussed, and this particular cart algorithm is based on Gini value, so it can be explored. Now, uh, I'm going to discuss about the just I want to show one graph here, like when we are going to uh, distribute, look at here outlook when it contains this sunny, overcast and rain. So I was saying that overcast contains all the records belong to yes. So yes is, we can see here, so that's the reason it becomes the terminal node or leaf node. And here mixture of records are there, I mean yes no. And similarly look at here yes no. That's why these nodes require to be further explored. And we have seen that humidity became the root here, and wind became the root here. And then after further splitting, we reached at the level of terminal nodes, and the records were perfectly classified. So when we use the uh, cart algorithm, and Gini value is being used as a impurity measure, so classification is going to be the same. And working by observing the working of this algorithm, we can see that every level we can interpret how this particular algorithm is, let's say, going to be, I mean decision tree is going to be constructed. Now, if we look at the further aspects of this decision tree problem, so we think about how these nodes are going to be, let's say, split, or what will be the splitting criteria. So whatever I have discussed till now, that is based on univariate splitting criteria. So splitting criteria can be of two types: univariate splitting and multivariate splitting. So if we look at the univariate splitting, so we have discussed already information gain and Gini index. Even not only discussed, we have defined also. And this is third one is the gain ratio. Gain ratio is nothing but it is the normalized value of the information gain. And a few other let's splitting criterias are there, that is likelihood ratio. We call it chi square statistics. It was explored by this the at Navy in 1959. Another criteria, Towing criteria. It is based on when our splitting criteria suffers from the Gini value. I mean, Gini index is not able to let's take the appropriate decision to construct the decision tree. Then what we do, we move towards this Towing criteria. If you are interested to read about it, then you can explore this particular literature given by Bremen. And another criteria for splitting is orthogonal criteria. This is a vector-based binary splitting criteria, and it can be explored with the help of this literature. So these are the few splitting criteria which can be explored. And in general, researchers, what they do, they apply uh, the very well known splitting criteria, that is Gini and information gain. But sometimes if we are going to explore these criteria, so maybe we can find out the let's a bit better accuracy of the model or better precision recall or F1 score values for a particular data set. And there are multivariate splitting criteria which can be explored if the researchers are interested to let's build the decision tree model based on the multi splitting criteria. So in this particular splitting criteria, what we have to do, we have to not only focus on only one attribute, even we have to give weightage to the multiple attributes. And very interesting thing is when to stop splitting. So as we have discussed in the particular previous slides, that splitting criteria was reaching to the let's terminal node. I mean, when leaf node is going to contain uh, all the records belong to a particular one class only. But this sometimes leads to the overfitting of the model. Am I audible? Am I audible, please?
Yes, perfectly.
Yeah, yeah, fine. Actually, the screen just I can see my PPT only, so sometimes I feel that whether audience are there or not. So that's why I'm confirming. So look at here, when to stop splitting. So forget about these splitting criteria. If we go with the whatever I have seen in the previous slides, like terminal node, I mean reaching with the number of records belongs to the same class, then it may suffer from the overfitting problem, because model is reading uh, let's very intense information from the data set. So it may be something like it is reading from the errors also. So that's the reason what we do, we sometimes we have to change the let's stopping criteria. We have to change the stopping criteria. So if a tree has very large number of splits and turns into a huge tree, such tree take times to build and can lead to overfitting. It can lead to overfitting. So what we can do, there are many ways to tackle this problem. through hyperparameter tuning. So stopping criteria comes under the this stopping criteria. It is a kind of one of the hyperparameter of the model. So many the criterias are there, like max depth. So rather than fixing that whether it will reach to the leaf nodes, what we can do, we can fix to the depth. I mean, the height of the tree will not go beyond this particular given height. Or maybe another criteria like mean samples split. If the number of samples belong to a particular node is going to be, let's lesser than this, then further splitting will not be there. And here mean samples leaf. So leaf nodes, we can fix the let's leaf nodes also. This much leaf nodes will be there. So by doing this, we can avoid the overfitting problem. But of course, if we are going to do so, it is not going to give the 100% accuracy, but of course it will avoid the overfitting. Now, pruning can also help us to avoid overfitting. So pruning, if you look at the pruning of the plants, so what we do, we cut the branches of the tree in the garden. So similarly here in the decision tree, pruning, that means we can dropping the edges, we are dropping the edge. So it helps in improving the performance of the tree by cutting the nodes or sub node which are not significant. So significance will be derived on the basis of their information gain or impurity measures. And basically there are two types of pruning: pre-pruning and post-pruning. So in pre-pruning, we can stop growing the tree earlier and prune or cut or remove the nodes that are having low importance. And in post-pruning, what we do, once our tree is built to its depth, we can prune nodes based on significance. So what we do in post pruning, first we can, let's build the model, whether it is in any height it can contain. And then after the measurement of the significance of the attributes, we can prune the tree. So these are the two approaches: pre-pruning and post-pruning. And of course it is going to be helpful when our model is suffering from the overfitting problem. Various advantages and disadvantages are there of the decision tree. One of the advantage of this decision tree is, it is, I have already mentioned that it very interpretable. And decision tree are self explanatory, and let's they are easy to follow. It can handle both nominal and numeric input attributes, I mean classification as well as regression problems. And decision tree are capable of handling data sets that may have errors. So erroneous data set can also be, let's I mean decision tree can be preferred over the data set which is having some kind of errors. And of course, if it is going to be the, let's going to learn from the errors, so it will suffer from the overfitting. And we have discussed already how to tackle the problem when the model is suffering from the overfitting issues. So these are the few advantages of the let's say decision tree problem. And of course there are a few disadvantages also, like most of the algorithms require the attribute will have only discrete values, like when we are applying the id3 and c4.5. So continuous values will, if we are going to apply over it continuous values, so we have to first convert it into discrete form with the range of the value, then only we can apply. So this is a kind of one disadvantage. And similarly, if we look at the divide and conquer methods, so they tend to perform well if a few highly relevant attribute exists. So the reason is, if suppose that the attributes are giving same let's say same information gain value. So in those cases, this particular decision tree is not going to be relevant. If you look at the outlook, humidity, wind, and temperature in the previous discussion, so information gain values were differing, and that's why outlook was chosen as a root attribute. Now if all these values are going to be the same, then in those cases decision tree may not be preferred. The greedy characteristics of decision tree leads to another disadvantage that should be pointed out. It is oversensitive to the training set, to irrelevant attributes, and to the noise. So already we have discussed, if it is suffering from these kinds of issues, so we have to tune the parameters somehow. And if it is not possible, then we can drop this particular algorithm and we have to look at some other relevant algorithms. Now if we look at the further extensions of the decision tree, so various extensions are there, like oblivious decision tree. So these are the decision tree which all nodes at the same label test the same feature. Despite its restriction, oblivious decision trees are found to be effective for feature selections. Fuzzy decision trees, till now, what I have discussed, one node, one attribute, belongs to the one node only. But in fuzzy decision tree, maybe one attribute is contributing in more than one node. Values is not going to be 0 or 1. One attribute is contributing in more than one node. So that is a kind of a tricky problem. It can be applied depending on the nature of the data. So in classical decision tree, an instance can be associated with only one branch of the tree, but in fuzzy decision tree, may simultaneously assign more than one branch to the same instance with gradual certainty. These are a few further extensions which can be explored. Literature indication is given. Incremental induction decision tree inducers for large data sets. And then we'll talk about security issues in the machine learning. So just give me 2 minute break and then I'll talk about machine learning security.
Okay, sir.
Am I audible?
Yes, sir, perfectly.
Okay, okay, fine. Okay, now I'm going to start the this particular portion. So, although many applications are there for let's related to security issues. Machine learning is being applied related to many security issues, but I think the objective of this particular FDP is, how machine it is not for whether machine learning is being applied for let's security issues. Actually it is meant for how machine learning suffers with the security issues. So we'll talk about both the aspects. So machine learning is transforming the field of cyber security by offering new approaches to detect, prevent, and respond to threats. So if we look at the applications, so it is being applied towards the anomaly detection, and of course it is all going to be a classification problem. Similarly, threat hunting, malware analysis, phishing detections. So we will be having the data, and classes will be there, so we will be, let's using the machine learning model to classify the data on the basis of where it is, let's having particular anomalies or not. So if we are going to relate it with the security issues, so it can be seen as a simple classification problem also. Although, of course, by applying the machine learning model, we are going to solve the security issues, but it is not related to the security issues of the machine learning model. Is it clear? Are you able to get it? Okay, fine. So
Yes, sir.
so a few recent studies show that machine learning models themselves face many security issues. So basically, I think if we talk about machine learning security, so these are the relevant parameters, or these are the relevant factors which we need to know. So how we can, let's suppose that your model is behaving well and its accuracy is high, its precision value is high, recall value is high, f1 score is high, but what about when your training data is poisoning? I mean, your training data is not pure. Suppose that you have collected a data set to train the model, and this particular, after training the model, you are going to deploy your model, and some attacker or some intruder, already modified your data set. Some malicious records are inserted in the data set. Then of course your machine learning model is going to be trained over that data set only, and it will behave, your trained model will behave accordingly as per the need of the attacker. Similarly, back backdoor in the training set, adversarial example attacks, model theft, recovery of sensitive training data, including model inversion attack and membership inference attack. So basically, these are the five major factors where attacker can attack to, let's change the behavior of the machine learning models. So we'll discuss these five factors in detail. But before discussing these factors, let's think about the nature of the model. So in general, machine learning models can be categorized into two categories: NN algorithms and non-NN algorithms. So NN algorithms are basically those who are based on neural networks, and non-NN basically, uh, let's say classical machine learning models like SBM, decision tree, naive based, many classifiers are there. So that are non-NN, and NN models are basically, deep learning models. So we have to understand that why machine learning models can be attacked, why machine learning models can be attacked. So we have to look at it like, when we are going to collect the training uh, data, we are going to collect the data. So you know that many times we collect the training data from somewhere. We are not going to collect it as a primary data. You primary data, that means you are going to collect it your own. And secondary, many times we collect the data in the form of secondary data. So training together is going to be not able to ensure that whether this data is correct or malicious. Error is another story. Whether data is having noise, data is having some kind of error, that is another thing. But malicious data, that means suppose that a record is given and this record is for no. This record is for no, but some attackers, modified this data and changed its label from no to yes. And your model, your machine learning model will learn from that particular record and will find that label is yes, but actually it was no. So if it is like a kind of intrusion detection data set, so of course your model, whatever it is learning, it will behave accordingly. And your learning, your training data set is already modified, already, let's moderated by some attacker or modified by some attacker. So in that particular I mean, in this particular case, your model will not get a pure data, or a kind of relevant data to, get trained. And then that's the reason this trained model will behave accordingly. So maybe it will not be able to identify the, if some kind of intrusion is there and you are passing the data, and it will say that no, it is not a kind of intrusion, it is let's perfectly fine. But so we can see that if we are modifying the training data, or training data poisoning is there, then it is not going to be relevant for the model. So this is one kind of security issues with the machine learning model. Now, pre-trained models from the third party. So you might be aware with the transfer learning. So when we are going to apply the transfer learning, and basically we prefer when we are going to apply the deep learning, and data size is quite small. Data size is not like, let's 10,000 images are there or 20,000 images are there. So in that case, what we do, we apply the transfer learning. So when we import the pre-trained models, so this the issue once again, maybe pre-trained model is let's trained with the data set which is already, let's having, let's poisoned information or modified information. So once again, if you are going to apply the let's transfer learning concept and going to use the pre-trained model, so we have to very cautious about from where we are going to fetch the models. And third point, a large amount of data comes from untrusted users. If we are going to have the 50,000 records, so we are not able to verify each and every records. 100 records, 200 records, you can verify. So untrusted user are third parties without undergoing effective data validations. So there is the chances of whether it is going to be the pure data or not. So these are the factors, which leads towards the why machine learning model can be attacked. Nowadays, researchers, those who are applying the machine learning models, they are simply collecting the data and started applying the machine learning models. They are not bothering about whether this data is clean or not, whether this the transfer learning model is, let's perfect or not. So we have to focus on these factors, and these three factors, indicates that machine learning models can be attacked. Now, if we look at the training set poisoning, so the malicious manipulation of the training set, aiming at misleading the predictions of the machine learning model is called the poisoning attack. Look at this diagram. Training set is there and some poisoning samples are inserted, like with the modified labels of the records. Now, model will learn accordingly. Your model will learn accordingly. And then if you are going the input, and of course, poisoning sample was there in the data set, and your model was trained over that, then of course it is going to be the biased model. So if you'll give the input, so output maybe degrade the performance, or maybe it will suffer from the error generic attack goal, or maybe error specific attack goal. So poisoning attack can be targeting the uh, let's non NN models. Non NN models, that means, we are talking about machine learning models, like classical machine learning models, in fact, like decision tree and SBM, or many other KNN model and naive based model. And the applications can be seen as anomaly detection, security detection, or biometric recognition system. Uh, and if you look at the NN models, so generative adversarial network is one of the very relevant example. Like, it uses the generator and discriminator. Two optimizers are there in generative adversarial network, and uh, it can suffer from, with the help of data poisoning. Now, backdoor in the training set, so the attacker can create a backdoor hidden in the training data set. That means, those who are going to apply the models, they are not aware that some attacker is going to insert some, let's say, malicious records into the data set. So in the training data, or in the pre-training model, in few piece of literature, backdoor are indicated as trojans. We call it trojans. Now, if we look at the adversarial example attacks, so I have mentioned already, GAN is one of the, let's say, relevant example. It indicates the disturbance in the input data, carefully constructed by an attacker to cause the machine learning model to make a mistake. Basically, it is for deep learning models. If you remember the Rasmika Mandana deep fake case, it was happened in November 2023. Uh, uh, a deep fake video was created by someone, and uh, with the name of, I mean, with the face. Uh, I mean, face was of Rasmika Mandana, but rest of the part belongs to the Jara Patel, which was a British influencer. And uh, then there was a case, FIR filed by the Delhi government, and then appropriate, IPC sections were applied. And if you remember, four people were arrested and actions were taken. Similarly, another case was with the Barack Obama. Barack Obama was there and his voice was there, but content was from somebody else. So this deep fake is going to be very risky nowadays. Many times, if someone is calling to transfer the money, and maybe you will hear a voice of your known one, but actually this voice is created by the deep machine learning, deep learning models, and you'll not be able to identify that whether it is a fake voice, or the voice of your known one. So many attacks are, let's being initiated with the help of deep learning models. And of course, people, researchers are working to find out the solutions of it also. So many researchers are working towards deep fake detection. Deep fake detection, that means of a deep if a deep fake video is being created, then it will be tested over a machine learning model whether it is a real video or fake video. And of course, if a deep fake video is being created with the generative adversarial network, so it is very difficult to detect, because generative adversarial network, it works with the help of two optimizers. A generator generates the fake images, and discriminator checks that whether it is fake image or real image. So this process continues, and generator refines, to generate the images, so that discriminator cannot discriminate whether it is a fake image or real image. So so if some video is generated by using this approach or using this robust technology, so of course, whatever the traditional tools we have to detect the deep fake content or deep fake video is not going to be let's useful. So of course, deep fake detection is nowadays very relevant, and researchers are working. Those who are interested, they can explore in this particular area. Now, another aspect we can see, model extraction attack. So attacker can steal the machine learning model by observing the output levels. So those who are, let's sophisticated attacker, so basically after observing the output of the model, they can let's classify that which kind of model is being used, whether it is let's a classification model is there, or regression model is there, or maybe deep learning model is there. And on the basis of this categorization, they will be able to find out whether it is being classified with the machine learning model or SVM model. So these kind of attacks are also there, but of course it is not going to be very easy. Robust or sophisticated attackers or intelligent attackers can do this, so we have to be careful about this, the model extraction attacks also. And if we look at the last perspective of this attack, so recovery of sensitive training data, the in this particular case, the two other types of attacks are like membership inference attack and model inversion attack. So member inference attack is a type of privacy attack against machine learning models, where in adversary attempts, matlab attacker can attempt to determine whether a specific data point was the part of model's training data set. And this can lead to significant privacy breaches, or especially when the training data contains sensitive or personal information. Similarly, if we look at the model inversion attack, so is a type of privacy attack where an attacker attempts to reconstruct or infer sensitive features of input data to train a machine learning model. So these are the uh, uh, five types of attack we can see. And we have to look at it with respect to classical machine learning model as well as deep learning model. And we have already discussed why machine learning models are, how these machine learning models can be attacked. So many literatures are there. People are working towards machine learning security, and you people can also look for it. And if we look at the conclusion of this discussion, so we can see it like decision trees are a valuable tool for security analysis, providing a transparent and interpretable way to make predictions. And of course, we have discussed very crucial aspects related to security and let's adversarial machine learning models. So you people can explore, and those who are interested to explore the machine learning model, so I'm going to show a link. You can find the relevant information from there. So these are the few references which I have used to prepare this particular slide, I mean PPT. And link is this one, this GitHub link. You can open and you'll see that many models, many research have been done towards the let's machine learning security. You can explore it. So that's all from my side. uh, thank you very much. If you have any query, so you can ask. And at the same time, I'm going to just show the information mentioned here in this link.
Any questions from the participant side?
Just look at this link. Is it visible?
Yes, sir.
Yeah, please. So you can see uh, awesome machine learning for cyber security. So multiple data sets are there, papers are there, books are there. So as per the let's theme of this FDP, machine learning and security, you can find the relevance. I mean relevant material from this particular GitHub link. You can uh, explore the future studies. Papers are there based on machine learning, deep learning, and suggested books are also there, which can be let's referred for the fundamental concepts related to uh, these security issues. And you can see some talks also related to let's uh, security and machine learning. So I think those who are interested, this particular link is going to be very relevant for them. So that's all from my side. Thank you.
Any questions from the participant side? Thank you, sir, for such an informative session. We really appreciate your efforts and time for sharing your expertise with us.
Thank you.
Thank you
Thank you
so
very
much, sir.
much to you and your entire team, madam.
Thank you, sir.
So may I leave now?
So you can stay with us for some time. We are concluding and proceeding with the validatory session only.
Okay, okay, fine.
As we come to the conclusion of our faculty development program, over the past few days, we have had the privilege of delving into the cutting edge topics, engaging with experts, and broadening our understanding of these dynamic fields. To continue further, I invite my co host, Ms. Shilpa Sharma ma'am, for the validatory session.
Thank you, ma'am.
Shilpa ma'am.
Now I request our respected director, sir, to address the gathering, sir. Sir, please.
Very good afternoon to all. Getting my voice?
Yes, sir.
Okay. Department of Computer Science and Engineering of James Engineering Management Technical Campus Greater Noida, successfully organized a 5-day faculty development program on recent technologies in machine learning and security. I would like to thank the prominent speakers, Dr. Karan Singh, GNU New Delhi, Dr. Tayyab Khan, Triple IT Sonipat. I would like to thank Dr. Satish Chand, JNU New Delhi, Dr. Harsh Khattar, KIT Group of Institutions, Dr. Kadambri, NIT Warangal, Dr. Yogendra Mohan, Northeastern Regional Institute of Science and Technology, Arunachal Pradesh, Dr. K. Govardhan, Jawaharlal Nehru Technological University, Hyderabad, Mr. Kanti Dharnikota, Senior Solution Architect, USA, and Dr. Sunil Kumar Singh, Mahatma Gandhi Central University, Bihar. I would also like to thank the organizing committee, and last but not the least, I would like to thank HOD of Computer Science Department, Dr. Lata, for the successful conduct of the said faculty development program. I wish all the very best in future. Thank you from my side.
Thank you so much, sir, for your kind words, sir. Now, I request our Dr. Registrar, sir, to conclude about the session, sir. Rajotia, sir.
Hello, everyone.
Sir.
Am I audible?
Yes, sir.
Okay, thank you. The 5 days FDP on recent technologies in machine learning and security from 29th of July to today's. I think, in my personal opinion, the theme of the FDP was very rightly chosen by the department so as to help all the faculty members, especially the researchers, to know more about the topic and get a deeper insight into the machine learning and the securities. The talk delivered by different speakers who were very judiciously selected from the top-notch institutions and collaborating this FDP with the security lab of the JNU, it definitely gives a broader outlook of this area, not only a broader outlook, but a greater deep insight as well. I was listening to Dr. Sunil for the last maybe around half an hour or so. See how nicely Dr. Sunil has concluded the machine learning and the security. Security, when we talk of, especially in the field of machine learning, where we deal with all sort of data. And these datas, basically, because since these are ultimately the key role players in our machine, and unless the data is authentic and well tuned to a particular application, the source of the data itself is a great source of security threat. And as a machine learning experts, we know that we can't simply put the data into the machine. We need to fine tune this data. And we have to follow a long strategy right from the collection of the data, knowing from the sources of the data, and cleaning the data, checking first the data, whether the data itself is complete in all respect or not. And once the data is complete, once it has been verified, corrected, then we need to further explore this data to gain more insight of it, build relationship and extract different features.
Checking first the data, whether the data itself is complete in all respect or not.
Yeah, that is the very basic
And
first
once
step.
the data is complete, once it has been verified, corrected, then we need to further explore this data to gain more insight of it, build relationship and
Hello?
Yes, sir. You are audible, sir.
There was some crosstalk.
Sir. Yes, sir.
Okay. I thought somebody is speaking. So after capturing the data, knowing the sources of the data, exploring the data, then maybe the next step is to split the data. And this splitting the data, what exactly we do, we, from the given data set, we find out whether the data, what what amount of data is to used for the training, what amount of data or what data is to be used for the validation, and what amount of data is to be used for the testing purposes. So this is how the splitting of the data. I think Dr. Sunil, again, he touched upon many aspects on splitting the data set itself. And still there are many more operations and the steps that can be done with the data. The ultimate aim of playing with this data is to find out the patterns. All these speakers talked a lot about the data and the data operations, whether they talk about the fuzzy, whether they talk about the traditional algorithms or so. But ultimate aim is to play with the data. And once we play with the data, I saw some slides of the Dr. Sunil. Dr. Karan also spoke of this security, different algorithms. Dr. Tayyab Khan, I was listening to, he covered up many aspects, what is happening in the industry. And so are the other speakers of the 5-day sessions. So I was looking at the climatic data, whether it's a sunny, whether it's rainy, whether it's a foggy, and so on. So based on those, you collect the attributes and then predict based on those patterns, based on the outcome of the machine. The machine gives me the patterns. Further, I can tune or program the machine based on this pattern, take some decisions whether I to do this or to do that. So out of these 5-day discussions, I think every speaker made their best effort in educating, in making the audience informed about this particular topic. And this will definitely help every one of us in our future, in our research area. I thank the organizers, Dr. Lata, the hosts, all the department faculties who were behind the scene, not visible, but they were all running here and there for the well conduct of this FDP. Other people who are not seen, not visible, not known to me, I think the appreciation goes to every one of them as well. Thank you, Dr. Lata and Dr. Shilpa, for inviting me for this talk. Thank you.
Thank you so much, sir, for your kind wisdom words. So I request now HOD ma'am to give vote of thanks. Dr. Lata ma'am.
I think the appreciation goes to every one of them as
ma'am.
well. Thank you, Dr. Lata and Dr. Shilpa for inviting me for this talk. Thank you.
Thank you so much, sir, for your kind wisdom
Now it is
words.
okay. Yeah.
I request now HOD ma'am.
Good afternoon,
Vote of
everyone.
thanks.
Yeah, good afternoon, everyone. On the
Okay.
occasion of our
I
FDP,
think the appreciation goes to every one of
Yes,
them as
ma'am.
well. Thank you, Dr. Lata and Dr. Shilpa for inviting me for this talk. Thank you.
there is echo.
Thank you so much, sir, for your kind wisdom
Now it is
words.
okay.
Yeah. I request now HOD ma'am. I think due to some technical glitch, echo is generated. So
Is this okay now? Shilpa ma'am?
yes, ma'am. Now echo is not present.
Hello, Shilpa ma'am.
Yes, ma'am.
Yes,
Totally
ma'am.
audible.
It's audible.
Yes, it's audible. Okay.
Yes, yes.
Good afternoon, everyone. On the occasion of this FDP on recent technologies in machine learning and security from 29 July to 2nd August 2024, organized by our CSE department, GemTech Greater Noida. First of all, I must say thanks to our Honorable Chairman, Sir, Dr. Amit Gupta, Sir, for encouraging us to conduct this FDP. And I'm grateful to our renowned Director, Sir, Dr. Sachin Yadav, Sir, and Registrar, Sir, Dr. Rajotia, who gave their continuous advisory thoughts for the coordination of this FDP. And I should say thanks to all my peer group, HODs, and colleagues who supported me throughout these 5 days FDP. Finally, my CSE organizing team, a special thanks to Miss Shilpa Sharma ma'am, Shilpa Gupta ma'am, Bhumika ma'am, Renuka ma'am, Suvidha, Gaurav Narkoti sir, Devendra sir, Alok sir, Rahul Deva sir, Shweta ma'am, Mayank sir, and Vivek, who always help me to coordinate and manage the things. And thanks to all speakers who accepted our invitation in a short notice. And last but not least, my sincere thanks to all participants who took an interest in attending this FDP. Finally, thanks to all, and I wish good luck to everyone. Thank you all.
Thank you, ma'am, for your motivation and inspiration throughout the program. I request all the participants to switch on the camera for a group photograph. I request everyone to switch on the camera for the group photograph. Thank you all of you. Thank you once again for your dedication and participation throughout the FDP. We look forward to see you in future programs. All the participant can leave now. Regarding the participation certificates will be notified on the WhatsApp group. Thank you all.